In our previous video, we've populated an autocomplete text with either live data or data from a local data source. And you see we can click on an item and it will select in our autocomplete text. We can also enter a location and a description. We also have latitude and longitude. In this series of videos, we're going to explore how to save this information to the local database, and eventually we can synchronize with a cloud data source. Now, what we have a plant, we've called this a plant so far. This is the scientific definition of a plant. It's not talking about a specific plant we can touch, but all plants called abelia. Now, what we want to save now is a specimen. A specimen is a specific plant that we can touch. For example, we see here Colereteria paniculata, but there are several of them in the world, many of them actually. So we have pictures of a specific Colereteria paniculata here at Spring Grove Cemetery, as you see here. And then we scroll on down and we'll see one at Cave Hill Cemetery. That's a different specimen of the same plant. One here in Cincinnati, and then one probably at Washington, D.C. So each of these are specimens of the plant called Colereteria paniculata, and that's what we want to save now. Now, in a previous video, we have already captured the global unique identifier of this plant. We want to associate that global unique identifier with the specimen. We also want the location and the description and the latitude and the longitude. These are the attributes that we want to save. So the first thing we want to think about is how we can encapsulate all of this into one data object, into one, as we'll call it, a data transfer object. You might also hear it called things like a Java Bean or a Pojo or something like that. But we need a data transfer object which can go between layers that captures all of this information. So I go to my DTO sub package, right click, and I'm going to say new, and then I'm going to say Java class, and we'll call this specimen DTO. To be honest, because we're already in the DTO package, adding DTO to the end of this class name is kind of redundant. But nonetheless, we'll go ahead and choose OK. Now let's remember what we want to save. Go ahead and choose yes. We want to capture several things. Let's capture a relation to the plant itself. I'm going to say private long, we'll say int, we'll change it later if we need to. Private int plant GUID. And then that is the global unique identifier. That's the plantplaces.com identifier. But we also have to keep in mind that we could have a new plant, especially if we're not connected to the network and maybe we're at a botanical garden, we see a new plant. So we might not have a plant GUID assigned yet. So I'm going to give it a secondary ID as well. Let's say private int plant cache ID, where cache ID is the local ID. Now, the specimen's going to be a whole new table, so we're going to need these for specimen also. Private int specimen GUID, and that's the global unique identifier on plantplaces.com. Private, and you know, as I recall, the database gives us back a long, the local database, so I'm going to make these both longs. We'll go ahead and make both of them longs. Just it can store a bigger number, that's all. Specimen cache ID. Okay, now what are the other things that we need? We need the latitude and longitude. Now here's a warning. We're going to get those back as doubles, but doubles has something called floating point arithmetic. As soon as I can, I want to convert these doubles to strings, and I want to consider them strings, because if we're not going to do math on them, a string is the data type that we want to use. If we are going to do math on them, we can continue to make them doubles, but the floating point arithmetic, if we do math, can introduce some inaccuracy in the far decimal places. And when we're talking about GPS, those far decimal places are actually significant. So I'm going to say private string latitude and private string longitude. Now, location and description. On the live Plant Places app, I have location set up just like plant name, so that you type, it auto-completes, and it gives you back an ID. We have not yet done that on this app, so I'm just going to store it as a string. Same for description. So let's say private string location, private string description. Okay, now right click, and we're going to say refactor, or let's say generate rather. Let's say generate, and then let's say getter and setter. Okay, all, and okay. And the one other thing we're going to want, so now we have a DTO, the one other thing we're going to want is a toString. Gosh, for this, the toString's a little bit tricky. Let me reorganize this a bit. Probably the description would be good, but we also want some information from the plant. Let me, just for the moment, let me just do a toString. Okay, we'll let Android Studio help us out on that autocomplete. And I'm going to say return, just for the moment, we'll say location plus space plus description. Though really what we'd like to do is reach into the plant and get the genus, species, common name as well, but this will work for now. And I save. Okay, that gives me what I need now to stub out a DAO. The DAO is how we're going to interact with our, in this case, our local data storage. What I'll do first, though, is declare an interface that has the methods that the DTO wants. Then in our next video, we'll create some unit tests around that interface, and then we will create a prototype that will help that unit test to pass. So for the DAO, I'm going to go up to the DAO package, and I'm going to right-click, and I'm going to say New, and then we're going to say Java class, and kind, we're going to say interface. And so I'm going to call this iSpecimen DAO, and I'm going to choose OK. Okay, that's fine. So for this, I'm going to say public void save specimen DTO. And you see why I wanted to create the DTO first, because I'm going to use it in my method signatures here. And that's important because if the internals of the DTO should change, I don't need to change this interface. I'm passing the entire DTO as one type, so if the internals of that change, it doesn't matter. It doesn't matter to this method signature because I'm passing the DTO as an entire unit. Now, let's also make another signature public. Let's hold the return type just a second, and we'll say search string search term. Okay, now I want to search and I want to return specimens that match the search criteria. But, well, in this case, I'm saying string search term, and what would those specimens look, what am I going to be searching on? More than likely, I'm going to be searching on the plant name. So I might want to say list plant DTO in this case, because if I'm doing a search with the search term, probably I won't be searching on location or description. I might be, but let's say I'm searching on the plant name. Now we're going to want the plant associated with its associated specimens. So I'm going to go over here, Alt-Enter, and we'll import the plant. I could potentially do one more. I could say, I could search on specimens, say public list specimen DTO search, and then I could say something like double latitude, oops, comma, double longitude. I could search for specimens that are, and maybe I'd add a range there as well, so double range. I could possibly search on specimens that are within a certain range of a certain GPS point, and then from those specimens I could go back to plants. So there are a couple ways we could do this, either by returning the plant or by returning the specimen. I'm going to go ahead and choose save. I need to add some JavaDoc. Typically we'll JavaDoc an interface. That means we can significantly reduce the JavaDoc that's required on the implementation class. So save the specimen DTO to the persistence layer. Okay. Return all specimens. Oh, well, let's see, all plants with specimens that match the search term. Okay, and I should fill out the param and the return, but for the sake of time, I'll skip that for the moment. Okay, return all specimens near a certain point. Okay, we might come back, refactor this later, and change this to plants. To be honest with you, getting plants was, yeah, you know, let's go ahead and do it now. Let's make it easier on ourselves and go ahead and do it now. So list plant DTO. The only trick is then, if we're returning plants that have specimens, we need some way for, whoops, specimen DTO is specimen. That's fine. If we're returning plants that are associated with specimens, we need some relation between those plants and the specimens. So I'm going to make a change to our plant DTO. And notice this is exactly what I talked about before. If we change the internal representation of a DTO, we don't have to change any method signatures like iPlantDAO, fetch plants that use that plant DTO as a complete type. So plant DTO, I'm going to say list specimen DTO. Specimens. Okay, list specimen DTO specimens. And what this means is this plant is associated with this collection of specimens. Okay, so once again, if we take a look at plantplaces.com and we look at the, just a moment, we take a look at the Coroteria paniculata, the golden rain tree. We know that the golden rain tree is the plant, and it's associated with these specimens that we have pictured here. So this would be one plant with, in this case, about 6 specimens. The list is a dynamic type that will allow us to have as many or as few specimens as we wish. I simply need to right-click and choose Generate, and then Getter and Setter, and choose our specimens, and now we're all set. So at this point, we've set up the interface, and we have set up the DTO. Now, test first design is a good concept and one we have not yet done. So in our next video, we are going to use some unit testing to do some test first design on this interface in DTO, and then we're going to create a stub that will satisfy that test first design, and then later we're going to create an actual implementation that should also hopefully let those tests pass. We'll see you then. Thank you.